Hi, today let's look at the Iterator Design Pattern. The intent of the pattern is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. So the idea is, if there is an aggregate object like a bunch of students, a bunch of persons, regardless of how the group of students or persons is done, the navigation is uniform. That's the idea. Here we need to note that without exposing its underlying representation, meaning the client code that is utilizing the aggregate object does not need to know how the aggregate is implemented or how the traversal is done. That's the idea. That way the client code expects a certain number of methods and they work regardless of how the aggregate object is implemented or how the iterator is implemented. Let's look at the pattern structure. So here is the iterator design pattern structure. There are two interfaces, aggregate and iterator. The aggregate has the create iterator method, and the iterator itself has first, next, is done, and current item. Okay, so what would happen if the iterator design pattern is not implemented and the aggregation at the aggregate and the navigation is in the same code? There would be several disadvantages, but the let's look at a code here. So here we have a student class that takes a name and ID as for the constructor, and then we have a group of students, a bunch of students, as the school object. Now the students are stored in an array list, and the navigation is also part of the aggregate object. So here we have first, next, and is done, and current item within the aggregate object itself. To navigate, we need to store the position of the navigation. So we are using the current position as the variable to store the location where we are at currently. So now this itself has become a block for us if we have to implement two iterators at the same time. Let us say one iterator is going from top to bottom on the school object and another one is going from bottom to top. That is not possible with one variable here. So there itself we have run into a roadblock, number one. And number two, because the code for navigation and aggregation can be separate, it should be separated so that the impact of any changes to either navigation or aggregation can be minimized and localized. So let us see an implementation of the iterator pattern. So we have two interfaces here, iterator, and which implements four methods: first, next, is done, and current item. And there's another interface, aggregate, that has one method, create iterator, which returns an iterator. We have here a school B iterator, and the aggregate object we are going to use currently is a school. The name of the class is school B, which extends the I aggregate, and it holds a bunch of students in an array list, and it has several methods, but the most important one for us is the create iterator. The create iterator method returns The create iterator method returns a iterator specific to this particular aggregate, and it takes the aggregate object as a parameter. So that way the iterator holds a reference to the aggregate object and has the ability to traverse it. All this code is available as a download at the link below the video. Okay, now let's look at the aggregators, the iterators. Okay, we have a one iterator, school B iterator, which has methods to go to the first position, the next, and is done. We have another iterator, school B iterator, last to first. So this goes from the bottom to the top. Now because we have separated the navigation logic from the aggregate, we are able to define another iterator which performs iteration in another way. This allows us to have a code that is easily understandable and maintainable. Now if you look at this, the last to first, the current position starts at the last element, and then the next method moves one position towards the front. Okay, and let's look at the program. Okay, here we have two aggregate objects, one which has students ABC, DEF, GHI, JKL, all lowercase, and similarly we have another aggregate object, and we are going to use it these students to fill the aggregate object SB, and there is another one SBLF, which is last to first, and each of these has the ability to create the appropriate iterators to iterate the object. So here we have the iterator SBI, which is a regular iterator, and for the next the last to first aggregate object, the create iterator creates another iterator which moves from last to first, and here we move to the first element and write the name of the student. Similarly we move next and write the name of the student. For the last to first we are doing the same thing, move to the first and write. So the output should be, for the regular iterator it should be from ABC to JKL, and for the other one it should be from JKL to ABC. Let's run this and see how it behaves. Okay, we see here that the one is going from top to bottom and the other one is going from bottom to top. C# makes this implementing the iterator pattern even more easier. There is an IEnumerable and an IEnumerator interfaces. If the aggregate object extends the IEnumerable interface and the enumerator extends the IEnumerator interface, then we pretty much have covered the iterator pattern in C#. Now the advantage of using the IEnumerable and IEnumerator patterns is it allows us to use the for each syntax to loop through the aggregator. through the aggregate object. So for example, here we have a person, and then we have, let's look at the person class. The person class has a name, and then we have a list of persons, a person list, which is extending the IEnumerable, and the IEnumerable has the method getEnumerator. Now this enumerator is what creates the iterator, the person enum. So the person enumerator, we have a person enumerator which is extending the IEnumerator, and it implements methods for the current, move next, and reset. And this allows us to use the for each syntax. So the basic idea of the iterator pattern is to provide a uniform way of navigating an aggregate object to the clients. So something that has implemented the iterator pattern, we know that there would be a move next, a first, a reset, and a get current item. So that's the idea. So the client code doesn't have to the client code doesn't have to change, and also because the navigation is separated from the aggregation, tomorrow if we have to change the underlying implementation of the aggregate, and the client code that is traversing the aggregate object still would remain the same, because the appropriate changes would be made in the iterator as well. Hope things have been clear, and it's easy to follow the iterator design pattern. Have a nice day.